Hello, everyone. Welcome to another episode of Math and Silly Hats, or questions. I don't know. This isn't an Alex topic. It could be an Alex topic. But this is a question I actually got from a former student. So, Jay, I'm going to answer your question about the Lattice method of multiplication. Let's get into it. So this is a common Facebook, Twitter, Instagram, whatever post where people are complaining about, why do my students have to learn this lattice multiplication method? I learned stack multiplication, blah, blah, blah. So I actually didn't know this myself, even though I had a master's program specifically to teach mathematics. So I was also confuzzled. I had a student explain it to me, and that's okay. It's all right to be wary of new things, but it's important to learn. All right, so I took a snip snop. There's way too big of a thing. Smallify that. All right, so oh, that's too thick. Thick boy. Back in the day, we just did 9, 1, 1 times 6, 9, and we do stacked multiplication like God intended. So 1 times 9 is 9, and 1 times 6 is 6. And then we put a 0 here, and then we work on the second digit. 1 times 9 is 9, and 1 times 6 is 6. And then we work on the third digit, so we got to make 2 zeros. 9 times 9 is 81. Carry the 8. And then 9 times 6 is 54 plus 8. 60, 62, 2, 6. And then you add them all up vertically. 9, 15, 8, 6, 2, 8, 5, 9. Now, so we do have 62, 8, 59, right? Well, why would you use this lattice method instead of just the normalies? So we set it up the same way. If we have 911 times 69, we're going to need, well, 3 digits and 2 digits. So we got to make a box that's 1, 2. Well, let's make better boxes.
A few moments later.
All right, so we got our lattice. You put your, well, actually, multiplication is associative, so it doesn't actually matter. 69, nice. And then for each of these boxes, so let me just kind of highlight my first box in this box. What I'm going to do is I'm going to multiply the 1 vertically and the 6 horizontally. 1 times 6 is just plain old 6. You put the 10s digit here, you put the 1s digit here. This is kind of simplifies the carrying, because carrying can get complicated in the stacked multiplication. And then we'll move on. Let's do this box down here. So the stack box down here, we got a 1 and a 9, so 1 times 9 is 9, 0 tenths. All right, you go forward with this process. 1 times 6 is 6. 1 times 9 is 9. This is not an exciting example. 9 times 6 is, here's where it's relevant, because I had to use my thinking brain and remember stuff last time. 9 times 6 is 54. So I'm going to write that in the 2 boxes. Again, 10s digit, 1s digit, and then 9 times 9, 81. Now, what we're going to do is, let me get rid of this YOLO and this green. Once we've done all our boxes, we're going to go on a roller coaster ride diagonally down each of these columns. So 9, we're going to sum them up. 9 is just 9. It's 9. And then we go down the next diagonal. 6, 0, and 9 is 15. 5 and 1. Then 1, 6, and 1 is 8. Let me add new color. So we're going down this diagonal. 1, 6, and 1 is 8. Then can't forget pink. 0 and 4 is 12. So 2 and a 1. And then finally, purple. 1 and 5 is 6. So 6, 2, 8, 5, 9. Other than the tedium of making the lattice, I think there's less memory in this one because it's very clear where you're carrying. And I find students that don't have as deep, they didn't upgrade their working memory storage capacity. This is a little bit easier for them to remember in their thinking box. So let's do one more example both ways. Let's zoop 25, and it's purple, times 158. I want some larger digits, so I don't just end up with 1s and multiplying. That's not interesting. All right, so maybe we'll get some of the annoying carrying happening. In stack multiplication, you're going to multiply your 1's digit of your first factor by each of the digits of the second factor. So 5 gets multiplied by 8. The resultant goes here. And then we carry. So this is for the 10's digit of the second factor. So like explaining this makes it not make sense. 5 times 5 is 25, plus this 4 is 29. So again, we got to carry. And then we got 5 times 1 is 5, plus 2 is 7. Okay. Now, when you start on the second digit, the 10's digit of the first factor, it gets multiplied by each of these digits of the second factor. But we got to start, because we're in the 10's, with the 0 over here. Why? Because that's the way this works. That's, I guess both of them just have kind of arbitrary, this is how it works. So 2 times 8 is 16. Again, I'm multiplying the 10's digit times this, 16. Carry the 1. Here's where if you're not using multiple colors, this might get tricky. I even put it above the wrong digit. It goes over here because it's going to go over this 5. 2 times 5 is 10, plus the 1 is 11. So now we've got, this isn't 12, but if you didn't have different colors, it might look like a 12. 2 times 1 is 2, plus 1 is 3. So you'd say, even saying it out loud, it is kind of confuzzling to explain, though this makes sense when you do it a lot for your whole life. 0 plus 0 is 0. 9 plus 6 is 5. Carry the 1. Again, we're carrying. 8 and 1 is 9 and 3. So let's do this with the lattice method. I'm going to pretend that I got just pencil and paper, and my brains, they're not working so good, but here we go, making a lattice. Okay, it might be sloppy boppy. I'm using the mouse. Give me some credit. All right. So we're going to multiply our 25 by 158. All right, so first I'm going to multiply 8 and 2. So I'm going to be working in this box. 8 times 2 is 16. Next, I'll work in this box. So I'm going to be multiplying vertically and horizontally. 8 times 5 is 40. 10's digit, 1's digit, and so on. So 5 times 2 is 10. 5 times 5 is 25. 1 times 2 is 0 in the 10's, 2. 1 times 5 is 0 in the 10's, 5. So now, once we've got all the lattice filled in, what we're going to do is we're going to work diagonally down. So 0 is 0, our last digit is 0. Then we're going to work here, 6, 4, and 5, 10, 15. So 5, and we'll carry a 1 up here. And then we'll include this and go all the way down here. So 1 and 1 is 2, 4 and 5 is 9. And finally, down here, 1 and 2 is 3, and 0 is 0. So 3, 9, 5, 0. So we got the same result, 39, 50. Obviously, these are equal, both correct. Those are both correct. That's true. So really, it's up to you which method you want to use, but I believe you may, if you're in middle school, be required to do this. So I don't know. There's the lattice method for parents, I guess. It's not that much more complicated. I had to carry in both instances, though for me, I think the carrying makes more sense. In the lattice method, you'll see I only had to carry this one time, whereas I had to carry 4 times in the stacked multiplication method, and even almost, these have to both be 1s, but almost put this in the wrong place, which would have screwed me up. So I think this looks nice, and maybe just for me who has OCD, maybe just the symmetry of everything and how nice it looks and everything aligning diagonally. It feels clean. My brain likes that. So also there's an additional step of addition, so more carrying in the stacked multiplication. I can't say it's simpler, because if you're bad at making lattices, or you don't have like a little tiny ruler that you can use in scrap paper, then it's kind of out the window, where you can just always sketch this on a piece of paper. They're equivalent, literally equivalent. If you're required to do this, here it is. If you don't want to do this, stack multiplication still works fine too. Just be careful and check your work either way. Hopefully this has been helpful. Have a fabulous day, everybody. Bye-bye.